In this lesson, we're looking at the equation of a circle. So before we come up with the equation of a circle, we want to make sure that we know what the definition of a circle is. So in the coordinate plane, circle is the set of all points that are a fixed distance, and we call that distance r for radius, and they are all the same distance from the center, and we call that center h, k. So in this diagram, we have a circle whose center is h, k, and the point P is any point x, y on the circle that is r units away from h, k. So we have this right triangle then created by connecting those 2 points and then making a right triangle to form them. And what are the coordinates of point A? Well, it would have the same x coordinate as P, so it would be x, comma, and it would have the same y coordinate as the center, so it'll be x, k. So x, k. So we found that this point is x, k. And we'll use absolute values to write expressions for the lengths of CAP. So CA is the absolute value of, well, I look at these 2 points, and since they're on a horizontal line segment, I'm really only counting the spaces. Since it's a horizontal line segment, the K, the Y coordinate is the same, so I'm going to kind of ignore that. So it'll be the absolute value of x minus h. And then the length of PA, my x coordinates are the same, they're both x, and so I can just subtract the y coordinates, so absolute value of y minus k. And then it says to use Pythagorean's theorem. So x minus h squared plus y minus k squared is equal to r squared. Write the equation of the circle, which we saw on the previous screen, was x minus h squared plus y minus k squared equals r squared. So why did we need absolute values when we expressed the lengths of the legs, but not when we wrote the relationship in step C? In step C, we squared the difference. Which guarantees a positive value. Like absolute value, step B does. Suppose a circle has its center at the origin. What would be the equation of that circle? If the center of the circle is at the origin, then your h, k is 0, 0, which means you'd have x minus 0 squared plus y minus k, y minus 0 squared equals r squared. When you simplify this, x minus 0 is just x, and x squared is just x squared. So you'd have x squared plus y squared equals r squared. So that's what your equation would look like. So we're writing the equations of circles. In example 1, part A, you see that we're given the center, -2, 5. We're given the radius, and we substitute in the h, k, and the r values, and then we simplify. So in part B, we're doing the exact same thing. We're taking 4 and substituting it in for h, taking -1, substituting that for k, and substituting in the square root of 5 for r. When we simplify this, we have x minus 4 quantity squared, and then y plus 1 quantity squared, because minus negative 1 becomes plus positive 1. The square root of 5 squared would be the square root of 25, which you should know is 5. Suppose the circle with this equation is translated by using this rule. What would be the equation of the image of the circle? Well, the translation isn't going to change the size of the circle, so I know the right side of the equation isn't going to change. On the left side, the center of my given line, circle, is 2, negative 4. And when I take that and apply this rule to it, then the new center is 5, negative 5. So my new equation will be x minus 5 squared plus y plus 5 squared equals 7. More practice writing the equation of a circle. Here's our standard equation. So x minus 4 squared plus y minus 3 squared equals 4 squared, which is 16. Part B, I have x minus negative 1 squared plus y minus negative 1 squared equals the square root of 3 squared. Cleaning this up, I have x plus 1 squared plus y plus 1 squared equals square root of 3 squared would be square root of 9, which is just 3. Sometimes the equation of the circle isn't given to us in standard form. Sometimes the equation will look like this, for instance, instead of in this standard form where we have a binomial squared plus a binomial squared equals the radius squared. And so what we need to do is rewrite this as a trinomial that is a perfect square trinomial, and we need to rewrite this so that it is a perfect square trinomial so that it can be rewritten as a binomial squared. And so what we're going to do is complete the square. And if a lot of what I've been saying so far in this example sounds like something you have never ever heard before, then you're going to benefit from my going back to the algebra on this before we move into the geometry of it. Okay, so vocabulary. A perfect square trinomial is a trinomial as far as our circle equations will go. Let's just think about it in terms of x squared plus 2a plus a squared. Now this could be rewritten as x plus a quantity squared. And so what we're aiming to do is, for instance, this blue expression I have here, that's the x squared and then the number times x. What I need to do is figure out the third number. Okay, so in algebra, hopefully, maybe not, but we can hope, a trick that might have been shared with you is if you have an expression like x squared plus a number b times x, you take this number, divide it by 2, and and square it, and that's the value that you want to add to that expression so that it can be rewritten as a perfect square trinomial. So now coming to this example, in the blue expression x squared plus 6x, I would take that 6, divide it by 2, and square it. So 6 divided by 2 is 3, and 3 squared is what I'm adding to that equation. It's 9. And then for the green expression, I take that -4, divide it by 2, and square it, keeping in mind that when I square a negative number, it becomes positive. So what I'm squaring is 2, and I'm adding it to both sides of the equation. So you saw that I wrote it in on the left side of the equation. Let me make sure that I write it in on the right side as well. So now I've got this equation where on the right side I have added 13 to it. And so now this blue expression can be rewritten as a binomial squared. So notice that this x is the square root of this x squared. Similarly, the number I put in this parenthesis is going to be the square root of this 9. So that's 3. The sign that I use is this sign. And then in the other parenthesis, this number here is the square root of 4, so that's 2. I use this sign, which is negative. And then on the right side of the equal sign, I have -4 plus 13 is 9. So now now that the equation is in standard form, I can identify h, k, and r to figure out where the center is and what the radius is. My h value is -3. My y value is 2. My r is the square root of 9, which is 3. So the center is -3, comma 2. And the radius is 3. So when I graph this, I put my center at -3, comma 2. And then the book is talking about using a compass. I'm not so much focused on the circle being perfect as much as you having an idea of how you could do this freehand. If the radius is 3, then I can go 3 spaces to the right, 3 spaces up, 3 spaces to the left, 3 spaces down, and try to sketch a circle passing through those points. It's not perfect, but conceptually, you get the idea, I hope, and that's what's most important. This your turn example, very much the same idea. The equation is not given to us in standard form, and so we need to complete the square in order to do that. Okay, so in the last example, notice that I had an x squared term and an x term. Notice in this example, I only have an x term. So if you think about it, x minus what number being squared would equal x squared? Certainly, that must be 0. And then plus this y squared plus 4y, I need to add something to it in order to complete the square, and that equals 5 on the other side of the equation. And the number that I'm adding, remember, is b over 2 squared. So I'm adding 4 to both sides of the equation. So I'm going to keep this x minus 0 being squared just so that we have a visual of what the h is. The h is 0. And then plus y is the square root of y squared. 2 is the square root of 4. And then the sign in between them is a plus sign. And on the right-hand side, 5 plus 4 is 9. So the center is 0, negative 2. The radius is 3. And move this grid down here so that I can graph it. So my center is at 0, negative 2. My radius is 3, so up 3, left 3, right 3, down 3. Connect the dots. Another kind of problem that you should be able to do with the equation of a circle is figure out whether a point lies on a circle. So I'm trying to find out in part A if the point 3, square root of 7 is on the circle that is centered at the origin and containing the point negative 4, 0. And so they plotted a point at the origin, they plotted a point at negative 4, 0, and then used that information to draw the circle. Well, if the center is at 0, 0, and it passes through negative 4, 0, that's why the radius is 4, because negative 4, 0 is 4 spaces away from 0, 0. And then they wrote the equation of the circle and got x squared plus y squared equals 16. They plugged in the x value of 3 and the y value of square root of 7 into the equation, worked it out, and saw that it does satisfy the equation of the circle. Same kind of problem. I'm given a point, 1, square root of 6, and it has a center, negative 1, 0, and the circle contains the point negative 1, 3. I'm trying to find out if the point 1, square root of 6 is on this circle. So same steps. I plot a point at negative 1, 0 and at negative 1, 3. I draw the circle centered at negative 1, 0 that contains negative 1, 3. So if it is centered at negative 1, 0, which is here, and it contains the point negative 1, 1, 2, 3, which is here, then I know that my radius is 3. So my circle would kind of look like this. The sketch of the diagram isn't what's most important. What's most important is coming up with this equation of the circle. So we substitute in negative 1 for h, 0 for k, and 3 for r in order to come up with that equation. So our equation is x plus 1 squared plus y squared equals 9. So I have 1 plus 1 squared plus square root of 6 squared, and I'm checking to see if that equals 9. Well, 1 plus 1 is 2, 2 squared is 4, square root of 6 squared is 6, and the right-hand side I didn't do anything to. Well, 4 plus 6 does not equal 9. So the point, 1, square root of 6, is not on the circle because the x and y coordinates of the point do not satisfy the equation of the circle. How did we know that the radius of the circle in example 3a is 4? Because the distance from 0, 0 to negative 4, 0 is is 4.